You know that feeling when you stumble upon an old notebook? Part of you is nostalgic, and let's be honest, part of you might feel a little bit of dread, especially if it's a math notebook. Well, today we're facing that feeling head on. We are going to decode a student's actual revision notes. We'll be tackling everything from stats to something called factorial equations. Let's see if we can crack these problems together.
And here it is. This is our source material, a real page from a real student's notebook. So this isn't going to be some abstract, theoretical lesson. Nope. We're seeing how these problems get worked out in the wild. We're going to use these notes as our roadmap, kind of like a study session, and we'll figure out the solutions together.
So what's the game plan? First, we'll get a handle on the basics of data. Then we'll see how to actually visualize it, which is super helpful. From there, we'll jump into the world of probability and combinations, calculating chances. And we'll wrap it all up by cracking some pretty cool factorial equations. All right, let's dive in.
First up, the absolute basics of statistics. You see, before you can do any of the fancy, complex stuff, you have to have a way to make sense of a list of numbers. This part is all about turning what looks like a random jumble of digits into a clear story.
So, you're staring at a string of numbers. What are they even trying to tell you? How do you boil it all down to its essence? Well, that's where our first three key tools come into play: the mean, the median, and the mode.
Let's really zero in on the data set right from the notebook. We've got 11 numbers here, and the student did something that is absolutely crucial. They put them in order from smallest to largest. That is going to be a huge help in a minute. The numbers are 2, 2, 2, 3, 3, 3, 7, 8, 9, 11, and 13. Okay, before we check any of the math, let's just make sure we're all on the same page with these terms. The mean, that's just the fancy word for the average. The median, that's the one right smack in the middle of the lineup. And the mode, that's simply the number that shows up the most often. Simple enough, right?
Now, let's look back at the notebook's calculation for the mean. It's great that the student showed their work. But one of the best habits you can ever have in math is to always double-check your work. So let's do that together, real quick. This isn't about pointing out mistakes. It's about making sure our process is solid.
So here's where it gets interesting. The most important part is adding up all the numbers correctly. The note says the sum is 60, but if we actually add them all up ourselves, we get 63. Aha! There are 11 numbers in total. So we divide our correct sum, 63, by 11, which gives us a correct mean of about 5.73. See? This is exactly why checking your work is so powerful.
Okay, so we've figured out the center of our data. But that's really only half the story, isn't it? Are all the numbers crammed together? Or are they spread way out? To answer that, we need to talk about quartiles and something called a box plot.
Before we peek back at the notes, let's break down this term, the interquartile range, or IQR for short. I know, it sounds super complex, but it's really just a way of asking, where's the middle chunk of my data? It shows you how spread out that main group of values really is.
And hey, what do you know? The calculations in the notebook are spot on. Here's how it works. You find the median of the whole set, that's 3. Then, Q1 is the median of the numbers to the left of that, which is 2. And Q3 is the median of the numbers to the right, which is 9. The interquartile range is just Q3 minus Q1, so 9 minus 2 gives us 7. Perfect.
So why bother with all these numbers? Because they let us draw this, a box plot. And this is an incredibly powerful way to see the data story in a single glance. That box in the middle? That's your middle 50% of the data, the IQR. And those lines, the whiskers, show you the full spread. It's a fantastic visual summary.
All right, let's switch gears. We've been describing data that we already have. Now, let's get into predicting what might happen. It's time to enter the world of probability.
Okay, this slide perfectly illustrates a core idea in probability. On the left, we're working with cards numbered 1 to 20. On the right, it's 1 to 16. In both cases, the goal is the same. What's the probability of picking a prime number? But look, the answers are different. Why? It's all because the total number of possible outcomes changed. That's it. That's the fundamental principle.
And really, it all comes down to this super simple 3-step process. First, you count the number of ways you can win, what we call favorable outcomes. Second, you count up all the things that could possibly happen, the total possible outcomes. And third, you just divide the first number by the second. That's it. That fraction is your probability.
Okay, so probability is great for finding the chance of a single event. But what if you need to figure out how many different groups you can make out of a larger set? Well, that's where combinations come into play.
So here's the problem straight from the notebook. You have to choose 5 boys from a group of 11. This is a classic combinations problem because the order you pick them in doesn't matter, right? A team with Tom, Dick, and Harry is the exact same team as Harry, Tom, and Dick. So the question is, how many unique teams are possible?
And the answer, which the note gets exactly right, is 462. Now that might seem like a surprisingly huge number, but that's really how many unique teams of 5 you can make from a group of 11. This was calculated using the combinations formula, which, funny enough, involves factorials, which is exactly what we're talking about next.
And for our final section, we're going to talk about this little fella right here, the exclamation point. No, it does not mean the number is just really, really excited to be there. In math, it has a very specific and actually very powerful meaning.
A factorial is basically just a shorthand for a big multiplication problem. You take the number and you multiply it by every whole number below it, all the way down to 1. So as you can see right here, 5 factorial is just 5 times 4 times 3 times 2 times 1, which equals 120. Now remember that number, 120. It's going to be important.
Okay, now let's apply this to the problem in the notebook. We're told that the factorial of whatever is inside those parentheses equals 120. And wait a minute, what did we just figure out? We just saw that 120 is the same thing as 5 factorial. This little substitution is the key that unlocks the whole puzzle. So, watch how this just flows together. First, we replace the 120 with 5 factorial. Now, if the factorial of one thing equals the factorial of another thing, it means the stuff inside has to be equal too, so 2x plus 1 must equal 5. And from there, it's just basic algebra we all know how to do. Subtract 1, divide by 2, and you get your answer. X equals 2. And just like that, we've cracked it.
And that's our whole journey through this notebook. Look at what we've covered. We started by describing data with mean, median, and mode. Then we figured out how to visualize its spread with box plots. We calculated the chances of something happening, and we finished strong by solving an equation with factorials. We've covered a ton of ground here.
You know, that's the real takeaway here. All these concepts, statistics, probability, factorials, they're not just problems in a notebook. They are powerful tools, like a new set of glasses for viewing the world, helping us find order in the chaos and make sense of the patterns that are all around us. So my question for you is, what patterns are you going to look for today?